Welcome back to my channel. Today in this tutorial I am going to talk about different types of transactional isolation level in Spring Boot. Transaction isolation levels are crucial in managing how concurrent transactions interact in a database. This guide explains each isolation level that are available in Spring Boot with detailed description, use cases, example and best practices. Each isolation level has its strength and weakness, which determines its suitability for specific scenarios. Before going to the detail of it, let's understand what is transaction isolation. Transaction isolations ensure that concurrent transactions occur without interference. It's maintaining the data consistency and integrity. It addresses issues such as dirty reads. Dirty reads means reading uncommitted changes from another transaction. It's also like doing the non-repeatable reads, like reading the same data twice yields different result. Phantom reads. A query returns different set of rows when executed multiple times within a transaction. So these are the things that actually this transaction isolation actually covered, that I'm going to discuss in the next coming presentations. So let's talk about those things. Let's understand what is the importance of this transaction isolation level in Spring Boot. Without further delay, let's going forward. So here if you see, there actually Spring Boot support 5 isolation type. First one is the default. Next one is read uncommitted. I will talk about the detail for each isolation in the latter part of this presentation. Next one is the read committed. The fourth one is the repeatable read, and the final one is serializable. So these are the different types of isolation types that support by this Spring Boot. In the next chapter I am going to talk about the first one, that is the default one. How we are going to use this, what is the benefit of it, what will be the key characteristics of it, and where going to use it. So now we will talk about this. The isolation default level delegates the transaction isolation setting to the database. It uses the database default isolation level. So that means it will going to use the whatever the database isolation default is set, that is going to use over here for this default one. If we talked about the key points of this isolation default is, it behaves according to the database configuration because it's a default properties. We are not going to override anything over here. We are just going to setting the or using the default database configurations. It's also flexible and suitable for application where default behavior suffice. Means we are just depend on the what is the default behavior, then this particular isolation is applicable. We are not going to modify anything for this particular property. Okay, if we talked about the common use cases, the applications that do not need explicit isolation level control and rely on the database configuration, means we don't need to do extra kind of configuration so that we can do multiple things. We are just relying on the whatever the controls database is having. Based on the database configurations, we are going to use this one. So this is the common use case of this one. Next we will talk about the example of it. Before going to the example over here, like here if you see the isolation default over here, like this one, if you see here within this transactional annotation, we are giving this property as isolation equals to dot default, right? This one. This label uses the database default isolation configuration, right? This one, default configuration. This approach is useful when the application doesn't need custom isolation level. Okay, when we don't need the custom isolation level, then this property is basically used. For instance, it suit application with light concurrency and non-critical data consistency requirement. If we see this example here, it's actually find all the orders from the database using this find all method, and we are just setting the status, and then it will just doing the update the data into the database. Okay, so it will take the default one, like isolation type is the default. Okay. Okay, next we will talk about the like read uncommitted. The read uncommitted means, suppose we are doing some transaction, so it may be actually having some the data which is still not committed into the database. Okay, that may be after certain time, if the transaction got rolled back, then maybe we are not able to get those data into the database. So this property actually it's also like read the uncommitted changes from other transaction. What it will do, basically it will do the dirty reads, right? So that's why actually if we check the key points of it is, it's actually high concurrency, means we can get all the data, then minimal overhead. It will also do the dirty reads. Dirty reads, I hope it's clear. Dirty read means we are also fetch the uncommitted changes from other transactions. So this is called the dirty reads over here. So this is the dirty reads. It's also doing this non-repeatable reads, and the phantom reads can also occur over here. So these are the things that actually cons actually over here. And what was the like benefit of it? This is the high concurrency and the minimal overhead. And these 3 points actually, these are the actually like advantages of this read uncommitted. Okay, next actually when we are going to use this one, as it is actually read the uncommitted data, so which might be still be rollback in some other transaction, right? So that's why we are not going to use this. Is not ideal for this non-critical application. Like it can be used for this analytics or logging applications where data accuracy is not crucial or critical. Then we are going to use this isolation level in our Spring Boot application. Okay, next we are going to talk about this. Okay, here actually we are going to check one example. So here if you see that this one like this property, okay, that in this way basically we can define into our code this read underscore uncommitted with this isolation level, and this actually fetch the data from the database and it will pin, so that it actually fetch the means uncommitted data which are still in database, that may be rollback in for other transaction also. So it's actually fetch all the data from the database. Okay, okay, now another one, that is read committed. Okay, so this isolation read committed labels ensure transaction only read the committed data, mean only the data that is like committed already, so that actually it will fetch the data. It's what it will do, it will basically avoid the dirty reads, right? As for the read the uncommitted, will mostly the issues with these dirty reads. So what it will do, it will prevent the dirty reads, and also the non-repeatable reads and phantom reads can occur, but it will actually prevent the dirty reads. Okay. Okay, the common use cases for this one, it's actually standard business applications where dirty reads are unacceptable but some concurrency is needed. Then we are going to use this isolation read committed. If we talked about one example for this one, so here if you see, this one, like how we are going to use this isolation read committed. Okay, so here this example ensures that only committed changes are read, preventing dirty reads during a fund transfer. It balances consistency and concurrency, making it suitable for standard financial applications. Like here if you see this, find this by IDs, and also then debit and credit, those are doing things, but it's actually not prevent the dirty reads for this one. This is the benefit of this one. Next we are going to talk about the isolation serializable. Okay, These serializable labels ensure transaction execute sequentially, providing the strictest isolation. Means it's actually prevent the dirty reads, non-repeatable reads, as well as the phantom reads. Right? So these three actually it prevents. Okay, but it's having some disadvantages like low concurrency and also having the high resource usage. Common use cases: financial systems requiring the absolute accuracy and consistency, such as reconciliation process. Then actually we are going to use this isolation serializable. Okay, now actually we are going to take some example for this one. So here if you see this one serializable, in this way basically you can use it. And here this ensure complete isolation by sequentially executing the transaction, making it ideal for critical tasks like financial reconciliations, where accuracy is paramount but concurrency may be sacrificed. So in this time we are going to use this one because it's a very critical operations. Whenever we are going to do some kind of the reconciliations, then we are going to use this isolation serializable. So these are the actually different types of labels, different types of isolations type that actually we are going to use. As I said, I'm just repeating once. Default means it's a like general purpose default setting. Read uncommitted means actually non-critical analytics. If we are doing, then we can use this one. The read committed, it's actually standard business application. Repeatable reads, it's for the like banking, financial applications, and the serializable means is for the critical operations. Now we will see that what are the best practices. So whenever we are going to choose the isolations type based on the requirements, obviously we can use this read committed for most business operations, repeatable read or the serializable for high accuracy operations. Okay, the benchmark and optimize for this one, like higher isolations level reduce concurrency, test and balance trade-offs. The leverage database features like ensure that database support the isolations level for your configurations. So these are the practices we are going to apply over here. So this is actually overall the things about these isolations types in Spring Boot applications. I hope it's clear to you all. So like that's like wrap up our tutorial on transaction isolation level in Spring Boot. We have explored these 5 isolations type, right? That also discussed like how each impact data consistency and performance in your applications. Understanding and choosing the right isolation level is critical for building reliable and efficient system, especially in scenarios involving concurrent data access. If you found this tutorial helpful, don't forget to give it a thumbs up, share it with your fellow developers and subscribe to my channel for more content like this. Feel free to drop your questions or thoughts in the comment section below. I would love to hear how you are applying this concept in your project. Thank you for watching and I will see you in the next videos. Till then, happy coding. Bye bye.